This is day 3 of Advent of Code 2025, and this challenge is called Lobby. You descend a short staircase, enter the surprisingly vast lobby, and are quickly cleared by the security checkpoint. When you get to the main elevators, however, you discover that each one has a red light above it. They're all offline. Sorry about that. Enough apologizes as she tinkers with the nearby control panel. Some kind of electrical surge seems to have fried them. Try to get them online soon. You explain your need to get further underground. Well, you could at least take the escalator down to the print department. Not that you'd get much further than that without the elevators working. That is, you could if the escalators weren't also offline. But don't worry, it's not fried. It just needs power. Maybe you can get it running while I keep working on the elevators. There are batteries nearby that can supply emergency power to the escalator for just such an occasion. The batteries are each labeled with their voltage rating, value from 1 to 9. You make a note of their voltage ratings, the puzzle input, for example, 9, 8, 7, 6, 5, 4, 3, 2, 1, a bunch of ones, and so on. So each number is an individual battery. The batteries are arranged into banks. Each line of digits in your input corresponds to a single bank of batteries. Within each bank, you need to turn on exactly 2 batteries. The voltage that the bank produces is equal to the number formed by the digits on the batteries you've turned on. So for example, if you have a bank with 1, 2, 3, 5, and you turn on batteries 2 and 4, that would produce 24 joules. And you cannot rearrange the batteries. You'll need to find the largest possible voltage each bank can produce. So in the above example, you have 9, 8, and 8, 9, and you can make the largest voltage possible by turning on the batteries labeled 8, 9, producing 8, 9 volts. This is 7, 8, creates 78, and then this is 9, 2. And then you go through, add the numbers together, and that is the output. All right, let's get started. So I'll start off with grabbing example and putting that in our text input, and I may as well get my actual input just so we can take a look. A lot of numbers there, so we'll go to here. So this will be pretty straightforward. So currently we've got each of the lines here as a string. Go through trying to find the highest first digit, and when you found that, you then go through trying to find the next highest digit. But if you find a digit that's higher, that becomes the first number, and so on. So let's start here with an int total, which will be for the output. I'll do for each bar line in input. We will then do int first equals 0 and int last is equal to 0. Actually, no, I should change how this is. So we'll do int best line with 0. Then we need to do 4 loops to grab the first number and then the second number. So yourself. Actually, no, you don't need to do that. Okay, something that we all do though. Let's just grab length of input. Oh no, there should be line dot length. Then we can do for each bar num in line. Actually, this one should be a for loop because we want to use integer to grab the one in front of it. Wait, no. Okay, no, we will go back to a for loop for each loop. Bring these first back up to here. Change it to num string. Then int num is equal to int dot trypass, and we'll do num string. I guess I need to do int num that's something. Alright, that's a character. I guess we can just change it to a string and then do that. Okay, so we've got num. We can do if num is greater than first, num first is equal to num. Then we can do else. Actually, this should be else if num is greater than last is equal to num. So we do that. We reach the end here. Then need to do best for line is equal to first times 10 plus last. Doing the first times 10 because it's the digit in the tens place, and we've currently got just a single number there. So we do that, then we can do total plus equals best line, and let's do console.writeLine d3 part 1 total. Okay, so we may as well run it now and see if that works. Okay, so we've got 371, which is not correct. Maybe we'll do a print over here to see what it's actually coming up with. Okay, so 98, 91, 84, 98. And it should be 98, 89, 78, 92. Okay, now I need to turn this to a for loop. So for int I equals 0, I equals 0, I is less than equal to length, I plus plus. We then do like this, we then do line I dot string, and we do if I did I greater than equal, less than equal to. So this should be less than So if I plus 1 does not equal to length minus 1, and we do that, because if we're at the last digit here, we shouldn't be adding that to our first string because there's no number after it that we can use. But something I also forgot is if we're changing the first number, we then also need to change the last number because it's using a last number that was before it. So when we go to here, we then first equals num, last is equal to 0. Last equals 0. So then that just resets it and then allows it to be set again. So let's try that. Okay, that didn't properly work. That would be an issue with this condition. I plus 1. Actually, this should it just be I does not equal length minus 1. Actually, yeah, I think that's what it should be. So let's try it again. Okay, there we go. 357. 357. So we'll now grab actual input, put that into here, and rerun it. And we got 17408. So we'll now go back to here and submit it, and that worked. So now on to part 2. The escalator doesn't move. Elf explains that it probably needs more joltage to overcome the static friction of the system, and hits the big red joltage limit safety override button. You lose count of the number of times she needs to confirm, yes, I'm sure, and decorate the lobby a bit while you wait. Now, you need to make the largest joltage by turning on exactly 12 batteries within each bank. The joltage output for the bank is still the number formed by the digits of the batteries you've turned on. The only difference is that now there will be 12 digits in each bank's joltage output instead of 2. So consider again the example from here. Largest for the first line is 98765432111. The next largest is from this one, 8 all ones, then 9 at the end. And for this one, starting with 4, going 3, 4, 2, 3, so on to there, and you're adding those numbers together. Okay, that's going to make things a bit trickier because we will need to properly manage which part of the string we're in. We need to make sure we add 12 from the end. We will now need to probably use an array for it. And each time we add a number, we need to go through the array, check, is it larger than that number? If it is, you clear that number and then remove the rest. Yeah, okay, I think that's how it will work. So let's get started with that by first grabbing this one, putting it back into here. We will grab part 1 and put that to here. And what changes do we need to make? So because these numbers are going to be much longer, let's use doubles for it. So get double and change this to double array, and we'll make that an array of 12. We'll keep this, and then we no longer need this part of it. And at this point, so when setting the number, it's probably makes more sense to iterate through it. So it'll be for the int array index is equal to 0, array index less than best line dot length array index plus plus, and it will essentially be this again. So if I plus 1 does not equal length minus array index, and num is greater than best line array index, you then do this is equal to num. Actually, I need to change these to double as well. So length you stay, num you change. We do that, and then we need to iterate from the next point forward to the end. So we'll do for array change int array change equal to array index plus 1. Then we're essentially going to do the same condition the rest of it, except using array change, and this will be best line array change is equal to 0. Okay, that seems to be good. And then for printing out, we would need to basically do the same iteration again. Actually, change this to doing the addition here. So it would be plus equals best line array index, then times, so because it's decimal math dot pow, and this will be 10, then 12 minus array index. First index being 0, we now have a length of 12. We want to times that by 10 to the power of 12, so it goes to the largest number, and then we do that. Let's run it and see what we get now. I've got no idea if that number is correct. 3121. Okay, no, we got that wrong. Maybe we create a new number here. Let's do line total, make that equal to 0. You then do this, and then do total plus equals, and then we can get a print on the line total before we actually submit it. We're still on that one, so that's good. Okay, so this is definitely not working. Oh, that's because what I should have done is, if the number's found, we then break from it. Okay, that's not working as expected. So I did 8, 9, and went all the way. So that means I would have done incorrect math for figuring out if it can be replaced. Ah, the issue is I did not equal. So I plus 1 should be, I think it needs to be less than the length, like that. Okay, that's not completely correct. Or does it just need to be I is less than? Okay, no, that's not working. I guess if we're also looking at the numbers for length. So what do we do for this one? It was if I does not equal length minus 1. So the minus 1 because of how far away this one is from it. Okay, so this should be I is not less than length minus 12 minus array index, like we did below. Let's try that. No, it's still not working. So the length minus 1 was for checking if it's in this position. Because I had a length of 12. Length of 12, we want to go 1. Well, actually, maybe we just need to get rid of... Oh, where is it? That does look correct. Actually, this would need to be 13. Because we're, I guess, to make it a little more readable. Minus 1 gets you to the end of the array. And then go backwards. But if you're the last position in the 12 array, and you did just 12 minus... Gee, I'm not sure. Maybe we just add another variable in here so we can better track it. So let's do last possible index. We'll start off with length minus 1. So if you are the last index in here, and here, this is your last possible one. But if you're further up, it should be 12 plus array index, not minus. I think that's why I was failing. So if I is less than that, because we're doing plus array index, it makes it higher up. That should hopefully work. That is working better, except we've got 0 here. So maybe we need to remove this -1. No, it's still not working. I did change the number though, but how did it change? Oh, the expected numbers. So 98765431, and that's 41. Oh, do I have too many characters here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh, does this need to be 11? No, that doesn't make sense. This might be just a problem here. That needs to be 11. Okay, so it didn't work for this one. Getting very close, but there's still something that I'm missing. Okay, I see a problem. So with last possible index, doing length minus 12, and then the highest array index here is 11 because it starts from 0 to 11. But in here we're doing less than. It should be less than or equal to. Maybe that's a problem. And that would explain why it's skipping 9 here and 8 here as well. Okay, so that 9, 8, that looks correct. We got 3, 1, 2. Okay, awesome. We're getting that now. So we change that back to our input and we rerun it. We have this very large number, which if we go back and submit it, was the correct answer. So, like this video, make sure to like and subscribe.